Welcome to a new video. I will show you my project to make an open-source AI that works locally and with a series of implementations such as fine-tuning Telegram bot, text-to-speech, and simple methods to do testing and save logs on the functioning of the bot. The code implements a chatbot that can interact with users both through the console and through Telegram. It uses a pre-trained language model to generate responses based on user input. Key features of the code include model training, allows additional training of the model using custom datasets. Telegram integration, runs a Telegram bot that users can interact with in real time. Text-to-speech, converts bot responses to speech using Google Text-to-Speech and plays the audio. Conversation recording, saves all conversations to a time-stamped log file. State management, saves and loads conversation history and model state. How the code works. 1. Imports and configuration. Import a libraries needed for natural language processing, model management, data manipulation, and Telegram bot functionality. Configure logging to capture debugging information, chat logs, and logs of various parameters and actions to track operation. Save knowledge. Saves the trained model and tokenizer to a specified path, ensuring the model can be reloaded later. Set the device configuration to use the GPU if available. Otherwise, defaults to CPU. Print device and GPU information for verification. Sanitize text. Cleans up the input text by removing invalid characters to prevent encoding errors, while preserving valid accented characters. Saves conversation logs to a timestamp file, capturing both user input and bot responses. Save conversation status and training status to maintain context between sessions. Loads the conversation history if it exists. Removes duplicate entries from the dataset to prevent redundant training data. Validate dataset. Validates the dataset to ensure it contains the required keys. Remove duplicates dataset. Removes duplicates from the dataset and saves the clean version. Load model. Loads the pre-trained model and tokenizer. If a save model path is provided and exists, loads the model from that path. Otherwise, load the default DialoGpt-Large model. Generates a response using the model and tokenizer. Maintains conversation history, handles text sanitization, and converts the bot's response to speech. Inference parameters. Inference parameters control how the model generates responses once it has been trained. These include temperature, controls the creativity of the responses. Higher values make the responses more varied, while lower values make them more consistent and conservative. Top K and Top P. Control diversity by selecting the best tokens up to K or P cumulative probability percentage. Max length, the maximum length of the response generated. Experiment with these and other parameters to see how they change the way your chatbot behaves. Text-to-speech. Converts text-to-speech using gTTS and plays it back using PlaySound. Sanitizes text before conversion. An MP3 file will be created containing the text recording, then immediately deleted once played. Train model. Allows additional model training using custom datasets. Handles dataset loading, pre-processing, tokenization, and model training with early stopping to prevent overfitting. For training, or rather for fine-tuning, I used a JSON file, formatted as follows: instruction, input, output. The instruction is the user's request to the bot. The input is additional information such as request search for today's weather. Output is the response that can be expected from the bot. All JSON files that will be detected in the given path will be concatenated and used for training, removing duplicates. Training parameters. Training parameters are settings that control how the model learns from data during the training process. These include learning rate, the rate at which the model updates its weights; batch size, the number of examples processed before updating the model's weights; number of epochs, the number of times the entire dataset is used to train the model; weight decay, a regularization method to prevent overfitting; max length, the maximum length of token sequences; other parameters, such as warm-up steps, gradient accumulation steps, etc. During training, temporary folders and checkpoints will be created in case of errors or sudden stops. Handler for Telegram, with the welcome message and chat history management. The bot will work like a normal Telegram bot. Once executed, you will just have to write in chat and wait for the bot's response. I implemented some commands to do in console chat. Save state to save the message history for the next start. Save consciousness to save the updated dataset. Even if this happens anyway, because the save command is called at the end of each training. And the command train to start a new training, which will take all the JSON files present in the indicated path and create the training. Imported libraries. Standard libraries. Warnings, torch, threading, logging, JSON, NumPy, datetime, OS, Shutil, Pandas, Traceback, Essentio. Third-party libraries. gTTS, PlaySound, Transformers, datasets, Telegram, datasets. Here is the training. The training and the parameters with which you train the bot, as well as the parameters with which you manage its interactions, can vary based on your needs, the size of the data, the processing power of your device and video card. The results can also vary greatly based on these variables. The time it may take to complete the workout also depends on your device, but generally, it is a long and hardware-intensive process. Important considerations for rebuilding code. 1. Installing dependencies. Make sure you install all required libraries using pip. From the console, you can install or update libraries. Two, GPU availability. Make sure your system has a compatible GPU and the necessary drivers installed. 3. Telegram bot token security. Keep your Telegram bot token private and do not share it publicly. 4. Dataset preparation. Make sure your datasets are formatted correctly and placed in the specified directory. 5. File paths and permissions. Update the paths to match your system's directory structure and make sure your script has read-write permissions. 6. Audio playback compatibility. Make sure your system can play audio files for the text-to-speech functionality to work. 7. Asynchronous programming with the Telegram bot. The Telegram bot runs in an asynchronous event loop, started in a separate thread. 8. Model size and performance. The DialoGpt-Large model is quite large and may require a lot of RAM and VRAM. 9. Error handling and logging. The code includes extensive logging for debugging purposes. 10. API licenses and policies. Comply with the licenses associated with the libraries and models you are using. In summary, this code provides a solid foundation for a conversational AI chatbot that can interact both via the console interface and Telegram. It integrates natural language processing, text-to-speech, and real-time messaging. By following the above considerations, you can recreate the code, customize it to your needs, and ensure it operates effectively and securely. Note: always remember to keep sensitive information such as API keys and tokens safe. If you have any additional questions or need assistance with specific parts of the code, feel free to ask.